Welcome. Let us learn how to find support reaction when you have shorter UDL using ILD concept. Okay, so let us draw, consider a beam or girder. Say you have a span of 50 meters. Okay, now there is a load which is shorter UDL. So the span of the UDL is just 10 meters. Let us take the load value, UDL value, as 20 kilonewton per meter. Okay, so my interest here is to find support reaction, maximum support reaction, either at A or at B. Okay, that is my interest. Okay, right. So first plot ILD for reaction A. Okay, so let us plot ILD for reaction at A. Okay, so just dropping down these 2 points, reference line, and 1 unit ordinate at A, 0 at B, and joining these two by straight line will give you ILD for reaction at A. So this we have discussed in earlier video lectures. So please go through them, how to plot ILD for support reaction. Okay. So once you plotted the support reaction, then how to place this UDL to get maximum reaction at A. Okay. So this is my interest. I need maximum support reaction at A. This is my interest. So how do you place this UDL? Let us say this is the head, this is tail of the UDL. For example, if it is traveling from left to right, how do you place this UDL to get maximum support reaction? So the reaction value is depending on the load value, that is 20, which is a fixed value, multiplied by the area of ILD occupied by the load. So if this occupies this 10 meters here, so this much area it is going to occupy. So for example, as load moves like this, it comes here. So this occupies this area. So by visualization, by physical observation, you can see that this load, if you just keep it here like this, I'll just go with a different color. So if you place the load like this, okay, so this 10 meters, it is going to occupy the 10 meter span. Okay, so if you keep your load like this, it is going to have maximum area of ILD occupied. Okay, and for any other position, it is not going to occupy more than this area. Okay, so that's why, how do you describe this position? The tail is on A. Okay, so keep the tail on A. Okay, so that is how you describe the position of the load. So once you describe the position of load, then find the area of the ILD occupied by this UDL, right? So load is 20 kilonewton per meter. Area comes to, if you want to find out area, it is, let us say this ordinate is y. So 1 plus y by 2 average of the parallel sides multiplied by the distance between the parallel sides, which is 10 meters. Okay. Now, once you know the y value, then you can know the area of ILD occupied by the load. Okay. So, how do you get y value? It is from similar triangles. So, this total span is 50 meters. And for smaller triangle, this span is 40 meters, right? So, this total is 50, right? So, by similar triangles, y, that is height, by base 40, height is 1, by base is 50. So I need y value which is equal to 40 by 50. 0 goes from numerator and denominator. It is simply 4 by 5, which is nothing but 0.8. Okay. So this height is 0.8, which means height at A is 1. Height at the head of the UDL is height of ordinate, right? Height of the ILD, or other way called as ordinate of ILD, is 0.8. Now you substitute this 0.8 to find area. 1 plus 0.8 by 2 multiplied by 10. Okay, so this is now is going to be the area. Now to get, our intention is to get a reaction at A, right? Maximum reaction at A. So that is 20 multiplied by this area, that is 1 plus 0.8 by 2 into 10. So this 2 goes here, so it will be 10. This is 1.8. So this is multiplication upon multiplication, you are going to get 180 kilonewton. Is the maximum support reaction that is possible for this load movement. Okay. So from A to B, whatever may be the position of this load, the maximum reaction that is possible is 180. So similar discussion you can have, even if it is going to occupy the position on B, if you want to, if you are interested in reaction at B, what is our B value? Similar discussion can happen. So the head has to be at B. This is head of the load, tail. So this plot ILD for RB. Okay. So this is 1 unit at B, right? Again, the last 10 meters that is going to occupy this area, this load is going to occupy this area, which is very much similar to this. And again, this is 0.8, this is 1. So if you calculate, it is again going to have the value as 180 kilonewton. Okay, so that is how it is going to be there, right? Thank you.